Hello and welcome to our latest installment of Solutions for Success. I am Jonathan Hamilton, President at Point Alliance, and this is our holiday edition. Our topic today is preparing for predictive analytics. We are joined by Jan Crow, our Director of Consulting Services here at Point Alliance, who has a wealth of knowledge around predictive analytics, tools involved, processes, different industry experience. And what she's going to discuss today is less about the technical tools involved and more around data preparation for predictive analytics. So Jan is going to share a little bit of her experience and expertise with us. And without stealing any of her thunder, we'll turn it over to her now. Thank you, Jan.
Thank you. Welcome, everybody. As Jonathan mentioned, we're going to be reviewing predictive analytics preparation techniques. Data preparation for predictive analytics is both an art and a science to use the past to project the future of your business. Each data set and business objective can be unique with varied data preparation challenges. One should have a clear objective for building a predictive analysis model. There are several objectives such as risk and fraud management, forecast revenue, financial modeling, social media influencers, marketing campaigns, operational efficiency, and many more. The only thing is, we need to choose accordingly. So let's talk about what predictive analytics is first. Predictive analysis is an advanced analytical technique that uses data, algorithms, and machine learning to anticipate trends and make business projections. Thanks to computational advancement, it is already possible to analyze large volumes of data to find patterns and evaluate future possibilities from its history. The concept actually originated in the 1940s when governments first started using computers. You know, those that occupied an entire room and served warlike purposes. But predictive analytics has gained far more relevance today, driven by powerful processors and new technologies. Another decisive factor for the rise in this technique is big data, which is the phenomenon of accelerated multiplication of information with 2.5 quintillion bytes of data being produced by humans every day. Therefore, an analyst's function is to situate themselves in this enormity of data, showing the possible directions to follow and looking for patterns in the middle of the vast pool of information. For this, the analyst can use data mining, machine learning, artificial intelligence, and statistics to collect, process, interpret, and translate that data. It is essential to clarify that this technology cannot predict the future. It only maps the probabilities based on what has already occurred. The vital question is not what will happen, but what is likely to happen. One of the most basic examples of applying this technique of analysis is cross-selling. It's the strategy of encouraging the customer to add complementary products and services at the time of purchase. Amazon is one such retailer who excels at this cross-selling based on customer purchase history. In companies, it is possible to use predictive analysis systems to predict possible customer behaviors based on their purchase history, interactions, and their profile. Therefore, product recommendations are usually much more accurate when the level of detail is appropriate and the volume of data provided makes for better sampling. I'm going to talk about one scenario. One of my clients wanted to actually use this approach, and however, the level of detail that they were capturing was not detailed enough. They wanted not just to predict purchase behavior, but also create a marketing campaign that was personalized, such as if a customer purchased flour, they might also be interested in egg substitute. But their products and customer profiles were only categorized at the highest category level of the food category rather than a lower level such as baking supplies or prepackaged goods. And therefore, making an assumption that if a customer bought flour, they might be interested in granola bars was a poor assumption, because that particular customer created baked goods using baking supplies and didn't distribute pre-made goods such as granola bars. My recommendation to them was to start categorizing their products and customers with a lower level of detail to make the recommendations more realistically meet customers' needs, thus improving the likelihood of additional product sales. Another poor product recommendation practice is to send out coupons to a customer that expires within days for the same product the customer has just purchased. The customer is not likely to purchase those same items right away and likely not before the coupons expire, or even before their next scheduled shopping trip. Therefore, using this type of customer purchase history and erroneously predicting buying behavior will make it difficult for predictive analytics of sales to actually be effective. Instead, the algorithm should look at purchasing behavior, including the length of time between shopping trips, to provide a more timely customer incentives and thus make it more likely the customer will return and perhaps purchase more of those items because of the discount coupon. In these types of retail scenarios, buying pattern, purchase history, and marketing incentives work together to help increase sales, and the same information can be used to predict future sales more effectively. Oops, I jumped ahead, sorry about that. So before you can actually prepare your data, you must define your objectives and goals. Questions and activities like these on the slide will aid in defining your objectives and thus help define what data you need and at what level of detail, and mapping the probabilities based on what has already occurred. So ask yourself, do you want to understand consumer behavior? Do you want to predict your sales trends? Or do you want to identify your most profitable products? Do you want to reduce the churn rate or turnover? Or even reduce production and operating costs? Or do you want to reach new target audiences? And then you want to define your goals of translating business objectives into analysis goals. Predictive models are only as accurate as the data fed into them. So what does it take to get it right when it comes to data preparation for analytics? When you've defined the objectives of the model, the next step in predictive analytics is to identify and prepare the data you'll use to build your model. Smart data discovery finds and explains significant key metric drivers that truly matter. It explains what happened, why it happened, and what will happen and how you can improve it. The following information touches upon some of the most important activities as outlined on the slide. So first, identify your data sources. Data could be in different formats or reside in varied locations and systems that may need transformation to a core set of attributes and formats. And when I say a core set of attributes, you could have varied systems that categorize data in a slightly different manner, and to be able to analyze that data, you want to synchronize them into a core set of categorization is one example. There is more opportunity in leveraging predictive analytics on the smaller, already consolidated data sources that exist within the enterprise, especially those within any SaaS-based business tools. This approach largely avoids, or at least minimizes, the data preparation headaches that can obstruct any predictive analytics initiative. For many outcome metrics, data is captured at various business process steps in multiple data sources. For example, a sales process might have data in a CRM, an email marketing program, an Excel spreadsheet, and an accounting system. If that's the case, you'll want to identify the fields in those systems that can relate, join, or land the different data sources together. If you're trying to capture changes in data over a time period, check if your data source is only keeping the current state of value of a record. A CRM, for instance, may only keep current state value for a record. And if you want to get a prior value, you will need to have a snapshot of the historical data stored or keep a prior value data in a custom field on the current record. The timeliness of data should also be assessed so that information from varied sources follows a similar timeline. For example, purchase information, costs, should align with sales information, prices. You don't want to apply an older cost model to current sales, as it would overstate or understate sales margins and skew future profit predictions. Or imagine making forecasts in 2016 about the oil and gas industry based on 2014 data, when 2 years later the per barrel price of oil dropped dramatically. The results would be disastrous. Another issue to watch for is seasonality. When you have a seasonal pattern, if you fail to analyze multiple seasons, you may get into trouble. For example, a stock analysis that includes only data from a bull market where overall stock prices are going up doesn't account for crises or bubbles that can bring major correction to the overall performance of stocks. Failing to include data that spans both bull and bear markets when overall stock prices are falling keeps the model from producing the best possible portfolio selection. Similarly, predicting energy consumption without taking into consideration seasonality and weather data, both of which directly impact the energy consumption for heating and cooling, can affect the outcomes of consumption predictions. Next, you'll want to identify how you will access that data. Sometimes you would need to acquire third-party data or data owned by a different division in your organization, or even from a third-party loyalty program management company. And programming may need to be done to extract this information from its various sources and load it into a central data storage. You'll also want to explore the quality of your data, seeking to understand both its state and limitations. The accuracy of the model's prediction is directly related to the variables you select and the quality of your data. You would want to answer some data-specific questions at this point. For example, is the data complete? Does it have any outliers? Does the data need cleansing? Do you need to fill in missing values or keep them as they are and eliminate them, or do you want to eliminate them altogether? Next, you'll want to consider which predicator variables to include in your analysis that may directly affect the outcome. In doing so, ensure that the variable data is clean and consistent. The order and meaning of input predictor variables should remain the same from record to record. Inconsistent data formats, example, dirty data, and outliers can undermine the quality of analytical findings. Determine whether to use derived variables that you feel might describe or influence the outcome metric involved. In many cases, a derived variable, such as the price per earning ratio used to analyze stock prices, would have a greater impact on the model than a raw variable would. Understanding your data and its properties can help you choose the algorithm that will be most useful in building your model. For example, regression algorithms can be used to analyze time series data, and classification algorithms can be used to analyze discrete data, and association algorithms can be used for data with correlated attributes. Individual algorithms and predictive techniques have different weaknesses and strengths. Most important, the accuracy of the model relies on having both a great quantity and quality of data. Your data should have a sufficient number of records to provide statistically meaningful results. and gathering relevant data, preferably many records over a long period of time. Pre-processing and extracting the features with the most predictive values will be where you spend the majority of your time. But you still have to choose the algorithm wisely, an algorithm that should be suited to the business problem. Data preparation is specific to the project you're working on and the algorithm you choose to employ. Depending on the project's requirements, you will prepare your data accordingly and feed it to the algorithm as you build your model to address the business needs. The data set used to train and test the model must contain relevant business information to answer the problem you're trying to solve. If your goal is, for example, to determine which customer is likely to churn, then the data set you choose must contain information about customers who have churned in the past, in addition to customers who have not. Similarly, the tool can be used to predict the acceptance of a new product on the market and understand which marketing strategies are most promising and anticipate potential operational failures. The quality of output does rely on the quality of input. The saying garbage in, garbage out is very apropos in this particular case. Data preparation is a critical success factor for achieving optimal analytical results. There are a plethora of tools and utilities that can expedite data cleansing and wrangling tasks. Predictive analytics is an iterative process that can continue with data and model refinements long after your initial solution has been defined and deployed.
Thank you very much, Jan. That was a great session, and hopefully people found some helpful insight in preparing for predictive analytics and understand better how to get ready. And then as a follow-on conversation, I guess, what to do once they're ready. So thank you again, Jan Crow, our Director of Consulting Services at Point Alliance, for that great session. Enjoy the rest of your day, everyone.